Dear electrospinning fans, I would like to welcome you on the grand opening on Elmarco webinar series of this year. After successfully completed webinars of 2024, we decided to continue and offer you again many interesting talks with experts from nanofiber world. This year, we would like to be more focused on industrial applications and discuss some interesting features which are so unique for nanofibers. Today, though, as a starting section, we are coming to promote one of the Elmarco services, and in particular, we will introduce and discuss a new opportunity of offering a workshop. This discussion will be moderated by Jiří
and Kateřina. Hello and welcome. Elmarco is introducing new hands-on workshop, Nanospider Techniques for Peak Performance. This specialized training will utilize the Nanospider NS3S500U, the smallest and the most versatile machine from our linear line. In this session, you will experience the advantages of the multi-wire process, learn to work with new collecting electrodes, and advanced process optimization techniques. We will also address your specific research and development challenges. This workshop is intended for research groups, electrospinning product developers, and anyone interested in nanospider technology. The acquisition of this knowledge and experience will also be beneficial for owners of previous models of nanospider, NS labs, and industrial facility operators. Elmarco offers a highly customizable 3-day training experience designed to fit your needs. To ensure the high quality of the workshop and maximize its potential, we prefer to focus on small groups of participants. Flexible date of workshop is available.
This workshop is dedicated to all users of nanospider technology who are eager to increase the production throughput and focus on process of scale-up. It is also used for needle-based experts who are curious to compare different methods of electrospinning and learn more about productive and easy to scale up technology.
As an electrospinning product developer, you may already have experience with nanospider technology and wonder whether our workshop will be beneficial for you. If you are facing challenges, we can help you overcome them and move forward achieving your desired product. During the workshop, we will focus on optimizing polymer solutions and fine-tuning machinery settings to enhance an electrospinning process. This workshop is highly valuable for nanofiber industrial producers. Whether you want to expand your knowledge of electrospinning, explore new opportunities to diversify your product portfolio, or achieve specific material properties, we can support you. Perhaps you already have a product but struggle with process optimization or upscaling. If so, we are here to help you find solutions and improve efficiency.
We offer to spend with us days of intensive experimental work and education, which will be highly customized to your ideas or requests. This work will be provided in the industrial environment with Elmarco R&D experts and in your preferred terms. So this workshop is meant for a maximum of 5 people from your team to ensure the quality and safety of the work. All practical work will be provided on Elmarco's latest model of linear line, a half-meter wide pilot-scale production machine named as NS3S500U.
The first day will serve as an introduction to the workshop. After your arrival, we will begin with a theoretical session where we will go over the workshop plan in detail. You will also be introduced to Elmarco and its product portfolio, followed by a guided factory tour. This will give you the opportunity to explore our facility and see firsthand where the nanospider technology is developed. Additionally, we will hold a discussion on eco-friendly developments in the electrospinning field. We will explore the benefits of using green solvents and sustainable polymer alternative
as well as strategies for making electrospinning more environmental friendly. This discussion can be tailored to your specific interests and requests.
Our Nanospider technology, known for its patented electrospinning process, continues to evolve towards higher productivity. The new design features multiple wires, significantly increasing throughput without changing machine size. The redesign of batch carriage combined with 3 wires offers versatility, allowing you to use different polymer concentrations and also different polymer solutions, making it ideal for research and development. For semi-industrial production, the peristaltic carriage provides a longer operation times with the option of 1 wire to 3 wires mode. Transitioning from 1 wire to 3 wires requires adjustment in recipes and machine settings. This topic we will cover in detail during the workshop.
The best way how to learn things is to actually do the job. You will provide a practical work on NS3S500U machine type, where you will experiment with a new type of carriages, means a liquid distribution tools. You will work with different collecting electrodes and evaluate the results. You will explore the spinning from 1, 2, or 3 wires and learn the differences. You will be taught how to increase the productivity and how you can spin different solutions at the same time.
In addition to the traditional wire electrode, we offer alternative collecting electrodes like the rotating electrode and endless belt electrode. During the workshop, you will learn how to easily swap components and work with different types of collecting electrodes. Using the rotating electrode, which is ideal for creating layers of aligned fibers, we will demonstrate how to produce these precise fiber layers as well as how to install and efficiently operate the system. We will also introduce the endless belt, which is available in 2 different material options. The endless belt serves to eliminate unwanted phenomena during the process and also as a mechanical support for spinning with the substrate. One of the materials can be used for direct spinning, allowing you to create layers without the substrate. You will have the chance to explore its benefits with selected polymer solutions and even prepare self-supporting and advanced layers.
On the second day, we will begin by spinning on electrically unsuitable material, observing undesirable phenomena as fuzzy fibers. Then we will replace the wire collecting electrode with an endless belt electrode and demonstrate its benefits. The endless belt enables to eliminate some defects and provides mechanical support for substrate. If you are more interested in the producing thick membranes, we can use the endless belt for direct spinning, utilizing its surface as a substrate to create high basis weight layers. Toward the end of the day, we will put the rotating electrode in the chamber and shift our focus to preparing samples from aligned fibers. You will learn what it takes to spin on a metal cylinder and how the process of creating aligned fibers differs from standard electrospinning techniques.
This workshop is a chance to share our expertise and help you optimize your Nanospider process. You will learn how key parameters like humidity, polymer concentration, solutions conductivity, and solvents volatility affect outcomes. For example, with relative humidity, we will demonstrate the advantages of precise control of process air using the NSAC 150, our advanced air conditioning system. This system ensures optimal environmental conditions for peak electrospinning performance. Additionally, Transitioning from one wire to 3 wires isn't just about adding wires. It involves fine-tuning recipes and machine settings. We will show you how to use the full potential of your machine to get your desired product. Customization is essential to our training. Whether you are interested in aligning fibers, eliminating defects, or producing self-standing membranes, we will tailor the workshop to your specific goals. We will also explore eco-friendly electrospinning practices and discuss sustainable research and development trends.
On the final day, we will focus on process optimization. We will examine the effect of relative humidity on spinability, fiber diameter, and the formation of loose fibers. Additionally, we will discuss solution preparation, exploring how solution composition impacts process behavior, dosing of solution to the wire, as well as macro and micro defects formation. One of the key topics will be upscaling the process from using 1 wire to 2 or even 3 wires. This is a crucial aspect of industrial production, and we will dedicate significant time to it through the workshop. You will also learn how to interpret static traces and optimize the process by adjusting spinning distances. We want to address your specific challenges, so the content that can be tailored based on your requests. After completing all practical sessions, we will gather in the meeting room to answer any remaining questions and wrap up the workshop.
So the program can be fully adjusted to your needs, except for day 1, which is already filled by factory tour and presentations. You can test your own chemistry, your own recipes, use your own substrates, and we will help you to optimize your own product. You may discuss the safety of used chemicals in the electrospinning chamber and having answered all questions related to used solvents and additives. Also, the theoretical part can be adjusted to your selected topics, such as substrate supply chain, specific applications, and scaling procedure. So how can you register? Please use Elmarco's sales email address at sales@elmarco.com. Describe your ideal scenario of the learning workshop and preferred days. Each request will be communicated individually. So before we open the discussion, we would like to extend our invitation to an extraordinary event we are organizing this year. We will share a few words about Expo 2025 taking place in Osaka, Japan. So this year, Elmarco is actively participating in Expo Osaka by organizing a 3-day International Industrial Nanofiber Innovation Conference. This conference will showcase trends, innovations, and modern processes in the field of nanofibers materials and their industrial applications. This will be presented by industry leaders and visionaries. As part of this conference, supplementary workshops will be also held to share valuable and practical knowledge on current hot topics related to nanofibers. Again, thank you for following us, and now the discussion is opened. For those who have questions, please use our Q&A section for filling the questions, and we are ready to answer anything you have in your mind related to the offered workshop. So we have actually 3 questions, maybe?
Yes, we have something. So the first one is the workshop like a course of electrospinning basics, or do the participants need some background of chemicals and electrospinning process?
Actually, we would prefer the participants to be already having some knowledge in electrospinning. We don't want to be the workshop as a beginning course for anybody. We really like invite people who has ever electrospun or actively using the electrospinning device, even if it is needle or needleless. electrospinning device, because we want to kind of go into the deeper, let's say, knowledge or settings or optimization of your product particularly. So preferably not very beginners.
Yes, thank you.
What else do we have here? There's a question right about the price for the workshop.
Yes.
So basically, we decided to put a price for the entire workshop to be 5,000 euros, which will cover totally the let's say 3 days activities, including some catering, which we'll offer here at Elmarco. Of course, it will be up to participants to be prepared to cover the travel expenses and accommodations.
Mm-hmm.
So maybe we can use some of the questions
Which we, yeah.
on the list.
Mm-hmm.
If there is, maybe there is one.
Yeah. There is the question about the conference in Osaka. Probably someone is asking us if he wants to participate in the conference, if he needs some paper, or he can just only participate.
Yeah, I think you can just only participate. So please use maybe the same channel. Or the best way is actually to use a website where you have the all the information how to register and how to participate. If you feel more comfortable, you can even write that on the same email address. It was addressed on the workshop, which is sales@elmarco.com. And we can answer you all details about the participation, but not necessarily you need to have your presentation prepared. Actually, the presentations are already selected. We have all invited speakers, so there will be actually no room for presenting anymore.
Mm-hmm. There is this other one.
What is the best support material to collect nanofabric, I think nanofibers, different than siliconized paper? Yeah, that's a nice question.
Yes, it's like a big question because it depends mainly what are the purpose of the nanofiber layer. If you want to peel it off from the substrate, mm-hmm. or if you want to use it with the substrate, mm-hmm. so you can try some kind of a polypropylene spun bond, or you can change to some mesh material, or we are currently for some processes we are mm-hmm. using polyethylene foil. It depends on the electrical properties of the substrate mm-hmm. material. It's up to you, and this is not possible to say there is the best supporting material.
Mm-hmm. Maybe one additional comment to that, as you could already see on the video, basically, we are introducing this new endless belt electrode, particularly for this purpose, to broaden the range of used substrate. So actually, we are coming with this solution to use even the substrate which has maybe lower conductivity. And without this electrode, will be not possible to be used in the electrostatic field. But with this new, let's say, innovative item, we can support the electrospinning even on those less conductive substrates.
Yes.
So that's the benefit.
There is other question: if the workshop is if there is any possibility to do workshop online, or is it like personal attendance here necessary?
Yeah, preferably, and I think it's even better for you, I mean, to come here to Liberec, actually to see the machine, to touch all the components, and to be really part of the team, that we can definitely show you the facilities and even introduce you to our laboratories. So you can use even the equipment in our laboratories for preparing your own solution. So it's definitely better if it is in presence, yeah, not online.
Okay, thank you. There is
Is there
Sorry?
anything? Could you add, or maybe this question from
From René Thomas.
yeah. Can you add multiple sample carries on a single wire?
Oh, this is tricky question. Like, it is not possible to do rebuilding the old version of the machines, because only adding wire, it's not the only change which we have made. But if you are interested in working with multiple wires and you are considering to buying the new type of the machine, we recommend you to join us at the workshop and to see by yourself it is good or is not.
Maybe just a little bit revising the question from Rennie, maybe she meant also whether we can add multiple carries, like carriages on the single wire, if there could be like more carriages on one wire, which I don't think it's possible in
I
the
don't think so.
current setting, yeah. But we can discuss in person, Rennie.
Yeah, discuss it with our design team, which are almost magical.
Yeah. If there is definitely a benefit, and we can see that it's really the crucial parameter, we can work it out. Let's say for the next design of the machine.
There was the question regarding the chemicals which we will use during the workshop, and I think I can answer it. If it follows our list of the chemicals which we are usually used, it will be mainly PA6, some polyurethanes which we well know, but we can work with your material. So if you have any chemicals which you want to try to spin on our machine, we can discuss it and we can make it work.
Yeah, of course, there are some restrictions already, related to maybe some highly flammable components or maybe some polymers, of course, which are very difficult to dissolve, and we are aware of it already now. So we can answer you right away that those polymers are not really wanted. But yeah, please come with your own idea and we will definitely discuss it internally and come with the answer.
Yeah. There is a question regarding the throughput of NS3S versus the old version of one-wire system.
That's the right question for you.
Yes, I spent a lot of time to proving that, and it's quite tricky to say some number for that, because it depends on the chemicals which are using in the chamber, and also depends your material properties.
And the setting.
Of course, it is connected with that. So let's bring your chemicals here and let's try it, and we can calculate the increase of the throughput together.
Yeah, but definitely we can already say now that it's higher, yeah, because
otherwise
we wouldn't be bringing the multiple wire system if the throughput is not changed. So definitely it's higher, but whether it's higher doubled or tripled, it's hard to say. It will be something between, yeah. And we will, as Jirka mentioned, do it exactly on your products. What else?
There is question about endless belt and if it is possible to fit it into NS lab.
Yeah, that's very frequently asked question actually, and the answer is not. So unfortunately, because the NS lab machine is really primarily meant for initial research. So for the designers who are starting with exploring, let's say, new polymers, trying to quickly exchange the carriages and work inside the spinning chamber much often, and providing some really small volume of samples. While the machine that we are introducing at this moment meter size in width and has already the multiple wire system that offers much more higher throughput, and it's more meant to production. So there we introduce also the possibility of exchangeable collectors. So Fortunately, this endless bell collector will not be able to redesign, because it's actually it's also let's say driven. Yeah, it means that it needs separate motor for it, and it will be very difficult to actually put it or redesign the machine in a way that there is an extra engine, extra motor implemented in already existing machine. So that's, I think, also the reason for that.
Yes. And there is the question about the economics of producing waterproof and breathable films on our machines.
Yeah, that's interesting, because waterproof films means, of course, that you are working with some additives. Yeah. Well, you can find some polymers which are already, let's say, hydrophobic and I mean, working as a waterproof material, but prior experience is that always some additives, even some surface treatment or already some chemicals needs to come in. And yeah, we have some experience in some content we can share the experience, but of course we cannot really give the right recipe at this moment. But let's discuss it. What are you interested in? And we can maybe even offer some samples to you for your evaluation first. And if you like it, then we can collaborate even in the research of waterproof membranes.
And if you will come with some product which you already have on our machine, we are ready to give you the price per square meter. We can calculate it.
Yeah, it's basically it's based on the real experimental work. So once the product is produced of any of our machines, even if you're working with NS Lab only, or the bigger machine, then anytime when the line speed is selected correctly for the final parameters of your product, then from that we can calculate the, let's say, the material cost already.
There is the question about the changing of the volume of the carriage, and if it is necessary to adjust the process parameters during the electrospinning. It is quite...
Like based on the volume?
Yes, just based on the volume.
Would you?
Simple question, no. We have several different... For the like a previous model, we have several reservoir for the carriages, 50 milliliters and 100 milliliters batch, and there is no difference in the settings of the machine for the producing the same product.
Yeah, basically this is just the volume of the, let's say, the volume of the reservoir, the quantity of liquid that you are dosing to the wire. So bigger the reservoir, you can use it for longer time. So your process is basically longer until your reservoir is empty and ready to be refilled. So that's only the question of time of spinning. I'm glad you're reading it, because
yeah. So I will continue with it. So there is a question if we commonly see the problem with fluctuating current in the machine when we are using aqueous precursor solutions.
Wow. If we see...
It depends what means fluctuating current.
Or maybe there's some discharges, or maybe not stable. Maybe they mean not really stable current.
But we are usually somehow seeing some waves in the current.
Yeah, but still it's kind of
similar.
Yeah.
Yes. So
depends. If it is like peaks going, it means that something is going on, right?
Oh, no.
If you have a suddenly really high current, it means either your wire is empty or dry, basically. So it means that there's no liquid coming onto the wire. Or what else it could be?
You can have
some bad humidity.
Yeah, definitely.
Thinking what else, or maybe some changes in your substrate. Even sometimes the substrate are capturing some moisture, and during the time the substrate is getting more and more conductive, which can cause some fluctuation in the current, because the current is basically the response of the voltage that you select. So it reacts on any changes that are related to conductivity in the spinning chamber. So either the increase of humidity, because we generate a lot of moisture, so again the current is changing, or the moisture is accumulating in the substrate, which has the same effect or similar, or the wire is dry, it could be, so there is no liquid coming into wire. What else it could be? And then basically it could be also you have no spinning, that the liquid is basically not spinnable. Either conductivity of the liquid is very high, that could be the reason.
Or is the low concentration of the polymer in it?
That's true. Or it's another way, it's very high viscose, that it's really very thick. So it means highly concentrated, so it's the order on the other side. So again, there is no spinning, so you could see some fluctuation of current because nothing is happening there. I cannot think of anything else at this moment, but please send us email. We like to discuss it also extra, not only on this online meeting. What else?
There is the question about how can the parameters of a lab scale machine be correlated with those of production scale machine during the scale-up process.
So first of all, I think we should say that we are very happy using our equipment, because that's the basic, I guess. So once you use the equipment, it's very kind of smooth step to go to bigger scale, because you already use the method of the electrospinning technology that we are using. So it's definitely much easier than to go from any other device. But of course, it required some optimization still if we are going, because you are spinning on one wire firstly, and then you suddenly go to 8 or 16 wires even in a multiple unit setup. So, but we have, I think, great experience and good experts in optimization for going to large scale. So I wouldn't be worried about it. Any?
So if you have any questions regarding it, send us an email and we can try to help you with the upscaling process.
That's a kind of common job that we do basically on daily basis here, that we provide some sampling. We call it sampling process. So people send us requests, and we usually spend 1 or 2, 3 days on the machine and producing the material you want in the quality you want and quantity you want. So that's pretty standard.
So there is a question regarding to the increasing of adhesion to the substrate, and if we can somehow, by adjusting process parameters to have better adhesion. In the industrial scale, we have some part before the chamber. We have some part which we call adhesion module, which can apply a glue on the substrate, which may increase the adhesion of the nanofiber layer to the substrate. But if we are talking about the lab machine, we have to work mainly with the chemical part, or we have to consider to get there some post-process, some heating and other things which may change the structure and get the better adhesion to the substrate.
I know there are already some substrates that are already kind of pre-treated. There is already adhesion on it. So when this substrate is coated with nanofibers, then and afterwards is, for example, laminated with other substrate that already the adhesion is basically already part of this substrate, that can happen as well. So in this way, you can improve the adhesion, of course. Other tip maybe is if you want to really improve the adhesion, then you should select the same material as your polymer. For example, we have very good experience if spinning, for example, polyamide 6 on polyamide substrate. So because of the similarity, the adhesion is very good. The same for polyurethane, spinning on polyurethane substrate. So that's advantage that just using the property of the polymer, and adhesion is already much better. It's improved. So it's not a...
There is following question, which when we were talking about these different or weird currents, and someone is saying that he has high maximum and minimum, very big difference between these peaks or these values.
During a spinning, yeah,
yes,
probably.
Yes, I get it like that.
Yeah, so again, I guess we need to repeat ourselves, because if you see the big differences and really high peaks, that something is wrong is happening in the spinning chamber. So you have to look carefully what's going on, whether make sure that you have really good spinning along the whole width of the wire. So you observe the wire and you see that each centimeter or each part of the wire needs to be really covered with the liquid. And so the spinning needs to take place from the entire length of the wire. That's important. And look at the right humidity. Maybe change the environmental condition in the spinning chamber. Definitely your current should remain sort of stable. Yeah.
Maybe you can try to check the adjustment of the wire inside the orifice. If it is well adjusted, the wire should be covered in the whole length. But if it is touching some side of the orifice, there could be some empty space which may increase these currents.
Yeah, so those are kind of common tips that we would think of right now, but it's very difficult if we don't know what you're spinning, like what polymeric system, what solvents. So it always needs to be related to the particular process you're working with.
If someone has own solution, can he come to us and during the workshop with it?
Oh, definitely. That's right for you. I mean, that's the occasion that we really like to support, because this is your own invention, your own product. So then please bring whatever you have, come to us, and we will go through the whole optimization process. Yeah, we can start from the scratch. Even better than to bring the solution, though, would be to bring the polymer and solvent. So we can start optimizing it really from the beginning. So really select the right concentration, because sometimes it happens that when you prepare your own solution and you not test it very well, you may increase or decrease the concentration. So once the solution is prepared, then it's then difficult to decrease is easy, but to increase it, then it takes some time. So definitely, if you have your own polymer or solvent, then bringing during for the workshop, and we can work with that. And
we can adjust the plan of the workshop to optimizing your process. So we can skip, for example, the part with the other collecting electrodes or other stuff. So write us an email and we can discuss it individually. There was some question. If someone wants to collaborate with us or with Elmarco and to submit joint R&D proposal, who should he contact?
I think the best way is to write an email to the general email sales@elmarco.com, because it goes to more persons. And please specify exactly what you need, and this email will be transferred to the right person. So that I think it's the easiest way.
There is a question regarding the substrate. If there is any good alternative to siliconized paper to improve the peeling of biopolymer nanofibers. As we mentioned before, you can try to use polyethylene films or some PTFE liner, but they are quite expensive. Or
yeah, we are now actually starting to work also with some biodegradable foils, so we can probably share that with you as well. These are kind of transparent foils which are also very smooth, and then so nanofibers will be easy to peel it off. But the most experience we have so far, as Jirka mentioned, is polyethylene foil. Yeah. But I guess it's not easy to find the right substrate, yeah, because we were also spending some time to look for the right polyethylene foil with the correct properties, because definitely the material needs to have certain conductivity to be able to be used in the electrostatic field and be stable. Yeah, that's very important. So. Yeah, we can definitely share some tips or some suppliers of those materials.
what are the electrospinning parameters that I can work on to optimize my formulations? So we are talking about chemistry behind electrospinning. So mainly you will start with the adjusting of the concentration of the polymer solution, like you can try to increase or decrease the amount of polymer in it, and then you can focus to changing the solution system, if it is possible for that polymer, or you can add there some salt to increase the
Conductivity.
Thank you. Conductivity, yeah.
Yeah. So there are more options how to increase or how to make your process spinnable, and but those questions are very difficult to be answered just by writing emails, yeah, because very often we need to see the process. So definitely if you are spinning on something, or preferably on our equipment, then we always ask people to send us even a short video, or how does it look like, or the best option, as we are discussing right now, is to register to the workshop and come to us, and we will definitely help you with the optimization.
And there is question about chitosan. Do we have any experience with that?
Yes, I mean the chitosan is one of the, let's say we call it a biopolymer, or it belongs to the category of biopolymers, because it's a natural polymer basically. And yeah, we have a recipe that we're using, spinning it from acids. We have experience of spinning chitosan, and actually chitosan is also one of the polymer that it's used for example in the area of facial masks, the cosmetics, and we know that already some products existing based on the chitosan nanofibers. So yes, chitosan is well known, let's say, a polymer, and it's been optimized also on our technology.
So
maybe I have a question, Jirko, to you. Is it possible to spin, let's say, different solution at the same time? I think you a little bit mentioned in the workshop.
Yes.
Maybe just to.
We can use a different solution, but they differ by concentration. It is very easy because the solvent system is similar, and very probably the surrounding or the environment in the chamber will be similar to each other, so we can do it very easily. More complicated thing is if we want to spin the solution which differs by the solvent system, like for example from acid and from DMF. We have to find the environmental conditions which are suitable for both polymer solutions, but yes, it is possible to do it.
And I think you also have experience with spinning two different polymers, yeah?
Yes.
Even different solvent systems. So yeah, I guess it is possible. Okay, thank you.
No problem.
All right. Any questions from audience?
Yeah, there are still some. There is the question about the price of industrial production line.
That's a very tricky question again. Okay, roughly we're talking about millions of euros. I mean, to be honest, because that's the investment for the entire technology. It's not just the electrospinning device, but we are, installing let's say, the key solution, the solution for your own product. So basically, it is related also to the selected peripherals that are belonging to the whole technology. So there is, for example, polymer mixing station. There should be some air treatment equipment which treats the air, because obviously when you are running industrial scale line, you're producing a lot of waste, a lot of toxic components in the air which is supposed to be treated. So it's another, let's say, component, another device that we are able to supply as a package. So basically it is very much dependent on the product you're going to make. Different scenario would be for, let's say, air filtration production also, because for the air filtration very often the nanolayer is very thin. So basically you can also run it with a fast speed. There are some peripherals that must be part of the setting. On the other hand, you may have some membrane setup where you, for example, don't need adhesion, because obviously you want to separate the membrane from your substrate. So there might be some peripherals that you don't need. So at the end, the total, let's say, price for this technology may be different. But we usually work with each customer very individually, starting really from the lab scale or going directly to big lines just to prove the concept of the product. And once this is proved, then immediately we can help you with the cost models. For the, even we can even drive the cost price per square meter of the material that it's produced on our line. So that's, I think, but it really needs to be done based on the trials, on the real experimental work. There was a question about some drug encapsulation.
Yes.
I've seen it. This one.
There is.
What are the methods of encapsulations that are suitable for electrospinning techniques? What are the methods of encapsulations? Well, I personally, I don't have much experience with, let's say, and I don't even know what exactly the word means. I mean, not literally, but practically what that means. We have experience with, let's say, editing of some nanoparticles into the electrospinning solution. So you would get maybe that's even your drug particles or some active ingredients in form of nanoparticles that can be electrospun together with some polymeric carrier. So basically they will become a part of the nanolayer. So that's, maybe we can call it kind of encapsulation, because already that nanoparticles is part of the structure of nanofibers. So we have experience with that. People are sending us or bringing us different, let's say, solution or different nanoparticles in form of dispersions, and we can help to spin it. To deliver some samples.
Also, there is possibility to spin some bioactive additive with the polymer. We have experience with CBD, which already worked well, but you have to always think about the solving system, which can't harm these bioactive material.
So basically, the advantage of the spinning it from the liquid is that you can add let's say, many ingredients into the liquid, which are, of course, compatible with the solvent system. But you can add the additives which dissolves in the same solvent, or you can add particles into the liquid system.
There is a question about producing multi-layers by electrospinning, and if there is any problem with the conductivity, and there are some troubles, I see. Yeah, it's a long question.
We can solve all your troubles.
Yeah, usually. Yes, it is possible to prepare multi-layer. In case of NS3S, you can do it by one-step production. You can use each wire for each polymer substances, and it depends on the process. Definitely, the covering of the substrate with the nanofibers will change the conductivity and the electrical behavior of this composite, but we usually don't see any big trouble with the recovering or creating another layer of the nanofibers on these composites. So if you have big troubles with that, please send us an email and we can discuss it personally or individually.
I think nowadays is also the trend to, in terms of, let's say, multi-layers or composites, let's say, to have one electrospinning or electrospun layer, and this is very often laminated with other layers to form kind of, let's say, sandwich of multi-layer system. So this is quite common practice, what I wouldn't say like a lot of, but there are quite some customers of ours that are working in that direction. But this is already like post-process system, yeah. It's must be done offline.
There was continuing about this encapsulation, drug encapsulation, and it is about trapping the bioactive agent in a droplet of a polymer. If it is possible to spin it like core shell kind of fiber.
Okay. So yeah, the core shell, unfortunately, well, for core shell for me is that you have, of course, the core and then shell around it. So you would need to use like a double needle, let's say, if talking about the needle system, that's, I think, is more common to use it. With our system, I mean, the wire, we don't have a method of how to spin a core shell, let's say, system. But probably there could be some other ways how you can achieve the mixing of the polymers. Yeah, we can combine even spraying with spinning. Because that's maybe interesting, yeah? I think you have quite a lot of experience.
Not a lot, but some. That. Yes, we did some like structure which was composed from the droplets of the polymer and from the polymer fibers. And maybe you can add this additive in the solution which will be electrosprayed, and maybe this is way how you can produce your desired product.
Because I think still we're talking about the industrial scale and we really focus on the industrial scale, then I think a core shell is not the way, at least at this moment, to be produced in a large scale. So if there are any other ways, and we are really looking at the other possibilities, how to combine, let's say, two polymers together, then we can help you to apply it either with electrospraying, electrospinning, or maybe applying some post processes. Some washing, for example. I don't know. People doing all kind of things as a post processing.
If we are working on upscaling the process from NS lab to industrial machine, how long time will it take?
That's also a good question. Yeah, I mean, sometimes it's right away. You know, if it is developed in a way that it's working very well on the lab scale. We have good fibers, there is no issue with the substrate, stable process. Then very often you just prepare this liquid in a large volume or solution in a large volume, put it in a large scale, and it works, yeah? But sometimes and very often it's with some highly evaporated solvents, happening that because of the large scale, because you have a large volume of the industrial electrospinning chamber in industrial scale, then of course the evaporation rate will be very much faster. So you have to adjust, let's say, the coating of the wire much more properly. You have to realize also that we're working with much wider systems, so not only 30 centimeter, but we have 1.6 meter, even 2 meters line. So of course then the evaporation rate and the liquid stability on the wire plays a kind of important role. So if it turns out that it's, let's say, problematic that the solvent that you select it's not very suitable, then we can recommend you to work with maybe different solvent or to look at other possibilities how you basically change the recipe if that doesn't work. So we have quite a lot of experience with upscaling because that's really our daily bread, basically, what we're doing.
There is another question about substrate, and there is about two conductive substrate. When we were releasing the endless bear, we were talking mainly about unconductive materials, but there is a question from the opposite side. So if the substrate is too conductive, it may affect your throughput. This is the main thing. And the second thing is that the electric current can escape from the chamber, so it can be dangerous for the operators. So please be aware of that. But you can try to use it.
Yeah, in that case, if you use it, in case of NS labs, it's fine because the collecting electrode is grounded. But in case of large equipment, we always recommend to use kind of a small voltage on the collector if using such a highly conductive substrate.
And you can also observe some discharges during the process.
You have to keep a certain distances, kind of larger distances between the electrodes to maintain kind of safe operation of the electrospinning. So we have 1 or 2 more minutes, let's say, before the end of the session, and I'm really happy that we have so many questions. We didn't expect that, and it means that you're very interested in, which is great. And don't worry that after this session it will be over. We stay here. We still stay here, and be ready to answer any question that's coming later on.
There is the question about PVA and carbon nanotubes.
Yes, carbon nanotubes are, as I understand it, something then you can buy it, carbon nanotubes, and then you can mix it with basically any kind of polymer. Some of our customers are mixing it with polyacrylonitrile. With PVA, I personally don't have experience with that. We would need to kind of look and ask internally if some of our colleagues maybe have experience with that, but I guess it's kind of normal practice, and it's again about the mixing, let's say, small particles into the solution liquid. It can be either nanotubes or nanoparticles. To me, it's very same thing.
There is another question about the substrate and if there is any limit of the thickness of the material. No, not really. It usually affects the properties, like electrical properties of the substrate. So you can try to use it whatever thickness you have.
Well, it just needs to be on the roll. Basically that's one thing that it needs to be rolled. So we cannot really spin on something very rigid because there is no system how you can wind basically the material through the chamber. Yeah, it needs to be always rolled, so it can be thick, but needs to be still placed in the roll. So I guess we are nearly at the end. Any more questions? We definitely will collect all the questions, and one by one we will answer them all. So I guess we can finish the session for today. Thank you very much for following us, and please contact us via the email address sales@elmarco.com regarding the workshop. With any other questions, specifically about the Expo Osaka, please visit our website because there are more or a lot of information there. And stay with us, for the next month. We're also going to meet at the webinar. Follow our website with the dates for next webinar. I think it will be also a very interesting topic, and see you next time.
Yes, thank you for your time, and we look forward to invite you to Elmarco.
Yes, okay, thank you. Bye-bye.
Bye.
Goodbye.